Good evening, students. Welcome to another video lecture. So today I am going to discuss about 4 cross 2 priority encoder with random priority. So basically, in the last video, I discussed about 4 cross 2 priority encoder with default priority. If we have four inputs like D0, D1, D2, and D3. So the priority order is like that. D0 is the lowest priority order, followed by D1, then D2, and D3. D3 is the highest priority order. If the priority order is changed, like if the priority order is given random, so you can take the example I have taken here. So you can see here D0 is the highest priority, then D followed by D3, then followed by D1, and D2 is the lowest priority. So in this uh, numerical or in this problem, I am going to discuss about how to design a 4 cross 2 priority encoder with random priority, and the priority order is given like this. The D2 is the lowest priority and D0 is the highest priority. So if you have any doubt about priority encoder, you can go to my previous video, you can check it there. So I'll start it directly. So when you want to write down the truth table, you have to write down either in the ascending order of the priority or the descending order of the priority. So here I wrote in the ascending order of the priority. So here I'm writing about the ascending order of the priority. You can see here D2 is the lowest priority. So D2 is the lowest priority and D0 is the highest priority. So I wrote it here from lowest to highest. So in the same manner, I wrote the inputs D2, D1, D3 and D0. So we have two inputs X, Y and V is the valid bit indicator. That is the valid bit indicator and it will show the output 1 when at least one of the input is 1. If all the inputs will be 0, it will not show any output. So output will be basically 0. So as I have four number of inputs D2, D1, D3, D0 and I wrote in the table in the same order of the priority in the ascending order from lowest to highest. Same thing I wrote in the table also. Okay, suppose all the inputs will be 0. So at that time, I am getting output don't care, don't care. At that time, valid bit indicator is showing 0. Now D2 is the lowest priority. So if D2 equal to 1, if D2 equal to 1 and all other inputs will be 0, so I am getting output here 1 0. So I am getting output 1 0. So basically, you can see that I am taking D2 here. So the output is giving x equal to 1, y equal to 0. So if you say that this 1 0 represents decimal value, so decimal corresponding value equal to 2. So D2, so as D2 equal to 1, so I am getting at the output 1 0 which represents the decimal equivalent 2. Next of the input, here D1 equal to 1, D2 will be don't care. So D2 will be 1. So D1 is the highest priority than D2. So I am getting output here x equal to 0, y equal to 1, which indicates the decimal equivalent value is 1. Okay. So whatever be the value of D2, it may be 0 or 1. If D1 equal to 1 and D1 is having greater priority than D2, so at the output I will can see the output having the highest priority. That means 1 because here 1 is the subscript. If I go to the next bit, you can see here D3, D3, D1 and D2 both will be 1. So D3, if I go to the priority order, you can see here D3 is having highest priority than D1, then D1 is having highest priority than D2. That means out of these three, D3 is highest priority. So at the output, I should get here 1 1. That means decimal equivalent value must be 3 because D3 having 3 is the subscript. So that means if D3 equal to 1, D1, D2 that may be 0 0, maybe 1 1, maybe 1 0, any value I will put here. That's why I wrote here don't care. So I'll get output here 3. We'll go to the last option. If D0 equal to 1 and D3, D1, D2 are don't care. That means that can be any value. That means if I'll take D0 equal to 1, D3 maybe 1 or 0, D2 maybe 1 or 0, or D2 maybe 1 or 0, I'll get at the output, I'll get the x equal to 0, y equal to 0. That means it will show the decimal equivalent value 0 because D0 is having highest priority and here subscript is 0. That's why at the output I'm getting output 0. So once this table is made, then we'll go to the find out the output versus input relationship. You can see here we have two outputs, three outputs basically, x and y, and we have four inputs, d2, d1, d3, d0. So basically we should get a four variable k map. That means we should construct a table of 16 possible combinations as you wrote in the case of default priority encoder, or you can directly from this table you can write it directly. So we have three outputs x, y, and v. So let us first I'll write down for x the same table I replicate here and I'm writing here. So you can see here first for x I'm writing and I have to write down the four variable k map here. So the, the most important thing is that when you are writing the k map, you need to write down the input variables, and this input variables will be the same order as you are writing in the table. So you can see here d2, d1, d3, d0. The same thing I will write down d2, d1, d3, d0. So this is a four variable k map. I will write down like this, and I am writing for the variable x. So I am taking this x. You can see here when d2, d1, d3, d0 all are 0. So x I am getting don't care. So I'll write down don't care here. Next, when I'm getting 1, when I am getting d2 equal to 1, d1 equal to 0, d3 equal to 0, d0 equal to 0. So here I can get 1, 0. So here I am getting 1. Okay. Next, when I'm getting 1, so here I'm getting 1. At that time, D3, D0 will be 1, 0. So D3, D0 will be 1, 0 here. So D3, D0 will be 1, 0 here. Okay. Next, D3, D0 will be 1, 0. At that time, D1, D1 can be any value. So D2, D1 is showing this row. So that can be any value. And when D3 and D0 equal to 1, 0, at that time I'm getting 1. So I can write down if this column taking all the value 1, then I can say that I'm getting output 1. So only these cases I'm getting output. Okay. So if I solve this k map and all other cases it is 0. So you can see that only in these two cases I'm getting output 1. If I want to solve this k map, so I can go for pairing like this. So I can go for pairing like this. So here I'll get here D3 D0 bar. So this is one possibility. And if I can take four corners, if I can take four corners, then also I can able to get here. So these four corners I can take. So by taking four corners, you can easily get. So it will be D1 bar. So it will be D1 bar, then D0 bar, D0 bar. So I can write down here. I can get X equal to D1 bar, D0 bar plus D3 into D0 bar. So this is the relationship between input and output for X. Okay, then we'll come to find out the variable for Y. So for that we'll take this column. So this column. So you can see here. So Y will be don't care when D2, D1, D3, D0 will be 0. So I'll get don't care here. Next, when I'm getting 1, so here I'm getting 1. For that case, D1 equal to 1, D3, D0 should be 0, 0. So first let me write down 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay, so I am getting 1 here. So for that D3, D0 will be 0, 0. D3, D0 will be 0, 0 here, and D1 will be 1. So D1 will be 1 here, D1 will be 1 here, and in these cases D3, D0 will be 0, 0, and D2 can be anything. So I'm getting, so basically I'm getting 1 here and 1 here. Okay, then here also I'm getting 1. For that case, D3 equal to 1, D0 equal to 0. So this is the case, D3 equal to 1, D0 equal to 0. So D3 equal to 1, D0 equal to 0, and for that D2, D2 and D1 value can be anything. So here I am getting 1. So here I am getting 1. Okay. So this is the this is the K map I got. So if I want to go for pairing, so I'll get this answer. So I can pair like this. So I can pair like this. I can get here D3, D0 bar. I can make a pair like this also. I can make a pair like this also. So for that I'll write down, it will be D1, then here I can get D0 bar. Okay, so why I will get D3 D0 bar plus D1 D0 bar. Okay, so this is the relationship between input and output for Y. Okay, as I told previously, so for valid bit indicator, always I'll get D0 plus D1 plus D2 plus D3. Okay, once I got the output input relationship, you can draw the logic diagram. Okay, I hope you can understand this numerical. If you have any doubt, you can ask me in this comment section. Okay, okay, thank you for listening.